Hi students, in this PLSQL programming unit, we have started to learn so many concepts. So in this session, we are going to explore explicit cursors using PLSQL. For this session, unit outcome is create cursor for retrieving multiple records in the given situation. And the learning outcome is students should learn how to declare a SQL cursor and its types, that is implicit and explicit cursors. So we have discussed about implicit cursors in our previous session. So today in this session we are going to explore explicit cursors. Before going to learn about explicit cursors, let's have a little revision of the concept of a cursors using SQL. So every SQL statement that is executed by the Oracle server has an associated individual cursor. So Oracle server or database server helps us to execute our SQL statements. So to execute those SQL statements, it requires memory area, and that memory area is nothing but context area. A cursor is a pointer to that context area, and PLSQL controls the context area to a cursor. A cursor holds the rows, one or more rows, written by a SQL statement. The set of rows or set of records the cursor holds is known as the active set. So it has two types, implicit cursor and explicit cursor. Implicit cursors declared and managed by the PLSQL for all DML, that is insert, update and delete command, and PLSQL select statements. And explicit cursors declared and managed by the programmer. So there is a reason or there is a need of explicit cursors because implicit cursors have some limitations. So limitations like these implicit cursors have no names, so user cannot control or manage these type of cursors, as well as these implicit cursors are not that effective when our SQL or PLSQL and SQL programs fetch or fetch multiple records as an exception, as an runtime error. So at that time we cannot control such a situation with the help of an implicit cursor. So user has to declare and manage the concept of a cursor manually, and that is nothing but explicit cursors. So let's discuss about explicit cursor operations. The Oracle server uses work areas, that's called as a private SQL areas, to execute SQL statements and to store processing information. So as I told you, every database server requires some memory to execute SQL statements, and that memory area is nothing but private SQL area. You can use explicit cursor to name a private SQL area and to access its stored information. If user wants to store the information about the operation which is going on, so user can access that private SQL area by declaring it, by naming it. The Oracle server implicitly opens a cursor to process each SQL statement that is not associated with an explicitly declared cursor. So here one concept is clear. Implicit cursors and explicit cursors are both different things. Implicit cursors are not depend on explicit cursor for their working, and explicit cursors are not depend on implicit cursors for their working. So using PLSQL, you can refer to the most recent implicit cursor as the SQL cursor. So every cursor has its own attributes like SQL percent found, SQL percent not found, SQL percent is open, or SQL percent row count. So these are the properties or attributes of implicit cursors, and we can use the same properties for explicit cursors also to get the information. So here we will learn how to control explicit cursors. So the very first step is user has to declare cursor in the declare section. So first of all, he has to create a named SQL area. So Oracle server or database server uses the memory area to execute SQL statement, that is nothing but Oracle or SQL private area. So user can access that area and you can name that area. So the next step is open the cursor, that is nothing but identify the active set. After declaration, the step open allows user to activate or to make active set available for usage. Now the next step is fetching the information from that active set. So the operation is fetch. So load the current row into variables. So why cursor is required? When we have only a single variable to store multiple values, at that time cursor is required, and to perform that operation we need to fetch information from that active set to store the information into variables one by one. So after fetching, we need to check whether that active set is empty or not. If it is not empty, then repeat the fetch operation, and if it is empty, then close that cursor. So here, while checking that active set, it is nothing but test for the existing rows, whether we can have multiple records to fetch or not. That is nothing but testing for the existing rows. Return to fetch if rows are found. So if cursor is able to find multiple records for the fetching operation, then that fetch operation get executed repeatedly until the active set is empty. So in the other diagram, you can see the first step is opening of a cursor, that is nothing but that active set is available and that active set has multiple records. So our cursor pointer refers to the first record. After that, the next operation is fetch the row. So you can see the cursor pointer is now on the second record. So here we are fetching, we are accessing number of records or the values one by one. So it is nothing but the array, continuous memory location. After, the next step is close the cursor. If cursor pointer is not referring any record, that means active set is empty, at that time we need to close the cursor so that we can free the memory area. That is the good habit. So here, let's see how to declare cursor. So in a declare section, user has to write declare, then cursor name, age, and select statement. So cursor is always associated to select statement in case of an explicit cursor. See the example in the declare section. Cursor name is C_EMP cursor is select employee ID, last name from employees where department ID is equal to 30. So the first is select employee ID, last name from employees where department ID is equal to 30, get executed. So that is very important step. After that, if this select statement is having 30 records or 40 records, that record set is nothing but active set, and our cursor will refer that record set or active set. So in a declare section, you can see one more example. V_location ID number : is equal to 1700. So you can declare cursor in that way also. Cursor name is select star from departments, means all column data where location ID is equal to variable name. So you have become declare cursor as per your convenience. So let's take one example for the explicit cursor. So in the declare section, you can see cursor name is C_EMP cursor is select employee ID, last name from employees where department ID is equal to 30. Then two variables are there. One is to store employee ID, that is V_EMP and the second variable is to store last name, that is V_name having data type varchar2 of 30. And then begin section, you can see the first statement, open cursor name. That means here we are making that active set available to use. That's why this open statement is required. After that, one loop gets started. It is a simple loop. The next step is fetch the cursor name into V_EMPNO and V_LName and semicolon. So here this C_EMP cursor, that is nothing but the cursor name, is referring to the active set, and active set is having employee ID and last name of those employee where department ID is equal to 30. So here we are fetching records from active set, and here we are storing those column data into V_EMPNO and V_LName variables respectively. Now we will exit from this operation when that cursor name, that is C_EMP cursor %not found is true. That means when the active set is empty, there is no record to fetch. At that time, we need to terminate this fetching operation. That's why we need to add this condition. So here cursor name %not found, it's a attribute of the explicit cursor. After this, you can display the employee numbers and last names one by one, and after that end loop statement is there. Exit when condition is true, then that end loop statement will get executed. After this operation, it is important to close that cursor with the help of a close cursor name statement, and then we need to terminate the block. So this is how you can declare the cursor, you can make that cursor available, you can fetch records from the cursor and store those values into the variable, and then you can free the memory area with the help of a close cursor name statement. So this is about explicit cursors using PL SQL.